All right. So what I wanted you to notice is the slope, obviously, because it shows you what the slope is of the two lines when they are perpendicular. So how do you know if the two lines are perpendicular? Because we can move this. Well, if you move that one around, it doesn't do anything. It just changes where the y-intercept is. But if you move this, then it changes. It's always gonna. This one is always gonna keep it at perpendicular. But how do you know that it's perpendicular?
It's the negative reciprocal.
Oh, I meant by you're a step ahead of me. By looking at the graph, not the slope.
There's a right angle.
Yeah, there's a right angle. And notice that the slopes are always the negative reciprocals. So this, if it's -3, the other one is positive 1/3. This one is -2, the other one's 1/2. -2/5, 5/2. What if you make one horizontal? The slope is 0, but what's the slope of this line? Undefined. So a horizontal and vertical line are perpendicular to each other, right? That makes sense. The x and y axis are perpendicular to each other. So that's part of what we're learning today. And also equations of parallel lines. Now you know that parallel lines will never intersect each other. And if that's the case, that means they're always going to have the same slope. So parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. And is there anything else up here that it says? I don't think so. All right, so you can go ahead and close out of that. So today we're just going to learn how to write the equations of parallel and perpendicular lines. This is going to be in 2 days. So we'll do parallel today, and then we'll do perpendicular on Monday. And you do need protractors, so let me pass out the protractors. Okay. So things we know about parallel lines is they have the same slope. Oh my gosh, sorry. Can you get that for me? It just flew out of my hand. All right. So anyways, parallel lines have the same slope. But they will have different y-intercepts. Because if they have the same y-intercept, then they're just going to be the same line. So different b, which is the y-intercept. The symbol for parallel lines are two parallel lines like up and down, but you draw them a little bit slanted. So it's like this, parallel. So that means parallel to. So we're going to make example of parallel lines. Does anyone want to give us just the equation of any line, slope-intercept form? Pick a slope and y-intercept. Zach.
Y equals 9x plus 7.
Okay. That might be tricky to graph, but we can do it. And then somebody else give a line that's parallel to that but has a different y-intercept. Ellen. Okay. Y equals 9x plus 2. It could even have a y-intercept of 0. It could be just 9x. So let's graph those two lines. And this is actually good practice for a question we'll do later that like the slope doesn't really fit on the graph, so you have to go backwards. So we'll plot 7 on the y-intercept. So there's 7. And then we can't go up 9 over 1. So what do we do instead? go down 9, and then left 1 to make it positive. So if I go down 9, I'm at -2, and then left 1 here at that point. So then we take our straight edge, and draw the line. And then do the other one. So the other one starts at 2. Once again, you can't go up 9 over 1 because it won't fit on the graph. So instead we'll go down 9 and left 1. So down 9 will be at -7 over 1. My graphs, my equations don't exactly look parallel, but that's okay. We know they're supposed to be. Okay, so those are examples of parallel lines. Now let's do a perpendicular one. Let's keep the same line, y equals 9x plus 7, but then let's draw one perpendicular to it. So parallel symbol, we would say like y sub, and then draw a little parallel mark there. That's how you can notate, hey, this is the equation of the parallel line. Where perpendicular, we would do y, and then put a little perpendicular symbol in the subscript. So let's go back up to perpendicular actually, because we forgot to fill that in. So the things about perpendicular is they have opposite reciprocal slopes. I say opposite just because, yes, opposite meaning negative, but if it's already negative, then it becomes positive. So think about it as opposite. So opposite, reciprocal slope. And then the y-intercept can be the same or different. If they're the same, then they'll just cross at the y-intercept. Same or different B. And the symbol for perpendicular lines is this. Draw a straight line and then straight line at the bottom. So then what would the slope of our perpendicular line be? Grayson? Yes. And then let's pick a y-intercept. How about, we could just pick 0. Let's just pick 0. So you could say plus 0 or just nothing. So intersects at 0, 0. And then it's going to go up 1 over 9. Or sorry, not up 1 over 9. Down 1 over 9 because it's negative. And then we can also do up 1, left 9. So you can draw 3 dots for that one. So that's y perpendicular, y, and then y parallel. All right. Now, something else to notice about numbers that are opposite reciprocals of each other. What if I take 9 and I multiply it by -1/9? What's 9 times -1/9? Negative, not -81, because the 9s cancel. Yes, -1, because the 9s cancel. So anytime you have slopes that are opposite reciprocals, like 2/3 and -3/2, they're going to cancel each other out because they're reciprocals, and then you just get -1. That is the property of perpendicular lines. So the main thing to write down here for your notes is that anytime you have m times m perpendicular, so I'm meaning the slope of the line times the slope of the perpendicular line, you get -1. I've seen questions on the air test that have an idea like that in the question, and it's a little bit tricky to understand, but that's all that means. It's just if you know what they're talking about, then it's easy. So we're just going to practice with writing the parallel slope and the perpendicular slope on the next part. So they give you the slope. So all of the parallel slopes will be exactly the same. So if it's 1/2, the parallel slope is 1/2. If it's -3, it's going to be -3. -4/5, 1, and then 0. So what would be the perpendicular slope for 1? -2. And then what about for number 2? Haley? 1/3. -4/5. Hannah? +5/4. What about 1? Grayson? -1. And then remember what it would be if it's 0? Undefined. Because remember, this would be a horizontal line, and this one would be a vertical line. Okay. Pages. And then we're going to practice identifying the parallel and perpendicular slope, but given the equation. So for question 6, the slope is 1/2. So it's just like the other page. If it's 1/2, the perpendicular slope will be -2. For 7, the slope is -7. So the parallel slope is -7. What's the perpendicular slope? It's positive. And then what's the reciprocal of 7? Maggie? Yes. Just like the 9 and the -1/9. Now for the next questions, we're going to have to solve for y to get the slope. So sometimes you'll have to do that. So with this one, I would add the 3 over. So we get 3x plus 3 equals 10y. And then divide everything by 10. Now the thing is, with these kind of questions, you don't need to know what the b is. You're not worried about that. You just want to figure out the slope. So it's not like you have to solve the entire question completely. You just want to get it down to solving it for y and figuring out the slope. So here the slope would be 3/10. So the parallel slope would be 3/10, and the perpendicular slope would be the opposite reciprocal, so -10/3. All right, number 9. Let's rearrange to get y by itself. So you could subtract 6x over, but to keep the y positive, you could add the 5y over and then subtract the 11 over. So you could get 6x minus 11 equals 5y. And then divide everything by 5. So what's the slope here? Hannah? Yeah, 6/5. So parallel slope is 6/5. Perpendicular slope, negative. Mhm. Okay, number 10, all we need to do is divide everything by 3. So once again, you don't need to rewrite the whole equation. All you need to do is figure out the slope. So here it would be negative 4/3. So same slope, and then opposite reciprocal, positive 3/4. So if you haven't done the last one, I'll let you have a minute to try it out. That's another one like 9, where I might just add the 5y over and subtract the 10. Unless you like just keeping y on the left side. But it really doesn't matter. So we get 3/5 for your slope and negative 5/3 for your perpendicular slope. Oops. Any questions about that? So just summary at the bottom shows you an example of parallel lines, example of perpendicular lines, and then the next pages we're going to be writing the equations. So the good news about these lessons is that the process is not new for writing equations of parallel and perpendicular lines. It's just like how we did it in 4.1 and 2, where we're going to plug in our given information either into point slope form or slope intercept form after we find out what the slope is. So the steps here, this is a good little summary of what you would want to do. I'll make sure that the equation is solved for y. It says borrow the slope from that equation. That says you can give it back another day. The reason you can borrow the slope is because parallel lines have the same slope. And then substitute the values for the point that they give you and m into the point slope form, or you can put it into slope intercept form. I kind of like doing it this way though, just plugging it into point slope form and then rearranging it into y equals mx plus b. Or sometimes it won't tell you what form to put it in, so you can just leave it in point slope form. But we'll also practice solving for y. So for the first one, it says write an equation of a line in slope intercept form containing the point 8, 3. And that is parallel to the line whose equation is that graph, the original line, and the parallel line. All right, so this says parallel. That means the slope is going to be the same. So m of our parallel line is going to be 3/4. But the b is going to be different. So that's the key thing. To figure out the b, we're going to use the point that they gave us and put it into point slope form. So they gave us 8, 3. So let's start off. I'm just going to write this below. I don't know where the rest of this question went. Oh, it's right here. Okay. So we know that the slope is 3/4. So we'll do y minus 3 equals 3/4 times x minus 8. And then rearrange to solve for y. So we'll distribute. 3/4 times 8 would be 24/4, which is 6. Add the 3 over. So we get y equals 3/4 x minus 3. So the b is negative 3. And we're going to graph the original line and the line parallel to it. So the original line has a y-intercept of 2 and a slope of 3/4. So we can go up 3 over 4 and down 3 over 4. And our new line has a slope or a y-intercept of -3 and the same slope. So up 3/4, down 3/4. And if you drew your line long enough, it would go cross through the point 8, 3. Any questions on that? Okay. The next one is same thing. So it says parallel. That means the slope will be the same as this line, 3/7. And they're giving us the point 7, -2. So the 7 is nice because I know it's going to cancel with the 7 in the slope. Let's set up point slope form. So y plus 2 equals 3/7 times x minus 7. Y plus 2 equals 3/7x. Remember, if I take 3/7 times 7, the 7's will cancel and you just get -3. Oh, sorry. Yeah, -3. Subtract 2 over. You get y equals 3/7 x minus 5. So there's -5 and then go up 3/7. And then the other one starts at -1. You can go up 3/7 and down 3/7. Oops, I think I went down too far. Here we go. All right. The next two questions you have to solve for y. So we'll go over the solving for y part together, and then I'll let you try this page on your own until the end of class. Which, by the way, the homework for this lesson isn't going to be due until next Tuesday since it is covering parallel and perpendicular lines. And I'll tell you the ones that you could work on and the ones I want you to wait on. Basically, the perpendicular ones I want you to wait on. But, I mean, I guess if you can figure it out, it's fine. Okay, so let's solve for y here. I would subtract the 4x over. So you get 3y equals -4x plus 9. Divide everything by 3. So y equals -4/3 x plus 3. So the slope of this line, the parallel line, is going to be -4/3. And it tells you to use the point -3, -2. So go ahead and try this one and the next one on your own. The graphing, you can wait until later to do the graphing. I really just want you to focus on getting the equation and the y-intercept of the new line. So once you get the equation, just move on to the next question.